right, so 7.2 is on parallelograms. So the definition of a parallelogram is a quadrilateral, so four-sided figures, quadrilateral with two pairs of opposite sides parallel. Okay, so those are parallel and those are parallel. So that's what defines a parallelogram. Okay, so then we'll go into like, okay, now that it's a parallelogram, what do I know? So there's four things that we know. So theorem 7.3 says opposite sides congruent. So if I have a parallelogram, opposite sides will be congruent like that. Okay. So theorem 7.4 says opposite angles are congruent. Okay, so opposite sides congruent, opposite angles congruent. Okay, 7.5. Consecutive angles supplementary. So any two angles in a row. So if I had angle 1, 2, 3, and 4. So angle 1 and angle 2 are supplementary, angle 2, angle 3 are supplementary, angle 3 and angle 4, angle 1 and angle 4. Okay, and that has to do with, if you go back to parallel lines, consecutive interior angles, which these kind of are, were supplementary. And so since the opposite sides are parallel, we create that same situation. Okay. And then the last thing that we know is that the diagonals bisect each other. Okay, so if we have the two diagonals, then each part of the diagonal, of the same diagonal, it's like that middle point where they cross is a midpoint. So it's the same distance on opposite ends. Okay, so those are the four things: opposite sides congruent, opposite angles congruent, consecutive angles are supplementary, excuse me, and the diagonals bisect each other. So if we had problem like this, a lot of the problems, they're not like super like crazy. So if it said, you know, it doesn't have to say it's a parallelogram, but if it's marked like that, where opposite sides are parallel, then you have a parallelogram. So very simply, you know, that first theorem said opposite sides are congruent. So x plus 4 equals 12. And opposite angles are congruent, so y has to be 65. So we could, you know, modify that and put, you know, 2y and change the 65 to something else. Like, you know, you can manipulate them like a little bit, but again, none of them are going to be, I guess in my opinion, super crazy. They're just going to be applying these basic theorems. Okay, I'm just glancing through, and nothing's going to be like all that wacky. So, you know, I suppose like the hardest one could be something like this. Well, you know, and again, if it's a parallelogram, either in the directions or labeled. So those are consecutive angles. So they are supplementary. So they're going to add up to 180. So if I combine like terms, subtract 20 from both sides, x equals 80. So a problem like that might be the longest one just because the equation's a little bit longer. Okay, but it should be pretty straightforward. Nothing too wild or crazy, okay? But the biggest thing, because there's a lot of information in this chapter, the biggest thing is to like remember, okay, I have a parallelogram, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So that means like on an equation you would make, if it's involving the diagonals, you're going to make them equal. The diagonals themselves are not equal. One of them is longer and one of them is shorter, but each part of the diagonal would be equal. Okay, so remembering those four theorems is really the biggest thing for this one, because after Thanksgiving break, we're going to talk about more shapes that are quadrilaterals, and some of them are parallelograms, but they're more specific. So we're going to add more information onto those shapes. So just try to get those four things memorized, okay? All right, have a great day. Sorry to give you an assignment on the Friday before Thanksgiving, but if I didn't, it'd mess up the rest of the semester. So get it done today. That way you don't have to worry about anything next week. Have a restful week, and we'll see you when you get back.